So we know our arithmetic operators. I don't know why I say arithmetic. It makes it sound aromatic. Arithmetic operators, addition, subtraction, multiplication, division, modulus. I believe we talked about the fact that there's also the ternary, also known as the conditional operator, which is that question mark, where you can do things like this. Message is equal to, I like using parentheses, although they're not necessary. Age less than 18, question mark, too young, colon, too old. All right, there's only two choices in this universe. Okay, so anyways, what that does is, whatever age is, it evaluates that. If age is less than 18, this value gets copied in the message. Else this value gets copied in the message. And in C++, unlike some other languages, you can really push this syntax to do some horrible things. I'm not going to condone that, but you can actually execute code rather than just copying values conditionally. If you're going to do that, just use if statements, because that's the same thing as doing this. If age is less than 18, message is equal to too young, else message is equal to too old. Those two things do exactly the same thing. Why would you do that? Well, if you get used to reading it, you know, it's shorter. It's one line rather than four. But if you're actually calling functions inside here conditionally rather than just passing values back, I think that's a step too far. So that's called the ternary operator, also known as the conditional operator, which is the question mark. Ternary meaning it takes three parts. It takes that one, and that one. Have we or have we not lectured about PEMDAS, P-E-M-D-A-S? I'm seeing some nodding heads, okay. Parentheses happen first, then exponents, then multiplication and division and modulus. And then addition and subtraction. So if we have this, x is equal to 3. Are there even exponents in this language? I do not recall. Anyways, 3 plus 6 times 9 minus 4. What happens first? Which gets evaluated first in that expression? 3 plus 6 does. So that gets evaluated. That turns into a 9. So now our expression is 9 times 9 minus 4. Then what happens? Does multiplication happen first or subtraction? Multiplication does. I'm only hearing one voice from the back. Are we sure we covered this? Yes? We're just sleepy? We're all good? Okay. Alrighty. So multiplication happens before addition and subtraction. So that makes it 81 minus 4. So when x is done calculating, it's equal to 77. There are a few more operators worth speaking of. This doesn't talk about them at this time. But there's the increment operator, and then there's the, oh gosh, what's a good name for that? My thoughts just blitzed. So if you do this, C is equal to 0, and in C++, that's where the language got its name. What is C equal to now? C now equals 1. Plus plus is called the increment operator. Now I remember the term compound operator, but I believe the book calls it something else. Okay. What about d int d is equal to 10, d minus minus? What does d equal now? Yeah, it equals 9. That's about enough until we actually hit the slides that cover this in further detail. There's also plus equals and minus equals. Int x is equal to 3, x plus equals 10. Once that executes, x now equals, can you guess? 13, yeah. And then if you do x minus equals 5, it's going to subtract 5 from it. X now equals 13 minus 5. Some books call those compound operators because they do math and they do an assignment. Two functions. There's also times equals, divided by equals, and even modulus equals. So you could do this. Int x is equal to 10, x times equals 2. What does that change it to? 20, yeah. We are just about done with this chapter. We're going to boldly go forward. Oh yeah, while we're here. That's kind of not spaced out, easy to read. I know I've made this comment before, but if you don't make 100 or 105 or whatever on an assignment, all it means is that I want you to revise it. You know, I'll knock 10 points off if it's late, and so revising it wouldn't help you then. But if you make a 1, that's just a strong hint to revise it. If you make a 50, it means you covered half the assignment, but there's still work left to do. So just go and read your feedback. I'll tell you what you need to do to earn the rest of the points. Alrighty, coding standards. I've had people ask for coding standards. What are coding standards? Coding standards are how you write your code in order to make it comprehensible to other people. And if you go and work at a company, they may have coding standards you need to follow. And coding standards can involve, among many other things, how you name your variables, how you name your files, how you put your braces and indentions, how you comment your code. So I want to walk through this document really quickly. Variable names should be meaningful. You shouldn't just use X and Y or I and J, etc., unless those are just simple loop counters. You know, if you're going to ask for somebody's weight because you want to calculate their BMI, you don't store their weight in X. And by the way, I have a question for y'all BMI programmers, but we'll get to that in a minute. Instead, you know, don't use I for interest rate, or don't use IR for interest rate. That should be a lowercase I. Thanks, Word, for capitalizing it. Use the whole word, interest rate, or interest underscore rate. Variable names should, within reason, contain units. Maybe not all the time, but, you know, height. Another programmer who walks up and is trying to figure out what your code does doesn't know what the height means. Is that height in centimeters? Where you're a European programmer, is it height in feet? Is it height in inches? Whatever. If you put height inches in it, that explains what it is. Weight kilograms. Temperature in C, you know, for Celsius. That kind of stuff. The more information you put, you know, you're not trying to write something that's as hard to read as possible. You're not trying to use as short of variable names as possible. If you use something that has multiple words in it, like patient name, put an underscore there. I'm sorry that it's underlined it all in red. I could have opened the PDF, except there wasn't one. I guess I could save it as a PDF. You gonna open my PDF for me? Here we go. Okay, so patient underscore name, or patient name with a capital N in the middle to make it easy to read. You shouldn't really use all capitals in a variable name because that means something specific, which we'll see in a minute. Is this stuff kind of picky? Am I going to fail you because you used patient name and you put too many uppercase letters in it, or you just call it PN rather than patient name? At most, I'm just going to dock some points off if I think that your variable names are egregiously too short. But probably not. But you need to learn this stuff because it'll help you in the future when you're looking at your own code and when you're working with a team. And it's likely that if you work in an agency with more than one other two other programmers, then y'all will probably have coding standards that you're expected to follow. Once you go into a workplace, it's a good idea to look at the other people's code and then match your practices to them. You don't want to just open their files and then change them all to your standards, and then save them again. Because then they're going to look at their code and they're going to get ticked off at you. So, you kind of have to fit into the culture. And part of the culture of your programming shop is how these things are done, whether there are written standards or not. We don't know what pointers are yet, but put P in front of the variable name if it's a pointer. If it's a static variable, you can put S in front of the variable name. If it's a global variable, you can put G in front of the variable name. What I actually did is if it was a global variable, I put G underscore, just to really flash that it was a global variable. Am I going to yell at you if you don't do that? No. Just be aware that these are standards that some companies follow. And they all follow different standards. There's no one standard that everybody abides by. Java has a more consistent standard just because it was created recently in the 90s, and it has one company that developed it, Oracle, or Sun, now Oracle, rather than the many, many, many developers who have contributed to the C++ language. So anyways, here's when you use capital letters, is when you're defining a constant. A constant is something that's defined with that keyword, const, but what you use it for is things that shouldn't change while your program is running. The speed of light should not change. The maximum age that your program allows should not change while the program is running. The number of items in your array you may define as a constant. Anything why do you define something as a constant? So that later on down in the code, if you issue the line max age is equal to 4, that might break other parts of the program. You really don't want that value to ever change. You would declare it as a constant so that if other parts of the code do try to change it, they cannot. That doesn't stop anybody from just opening your CPP file and typing in a different value there. It's not like it welds the file shut. But as far as the code is concerned, as far as the source code is concerned, once you declare a constant and give it a value, it's fixed until you edit it and change it. There's something called enums. We haven't talked about enums yet, but just give them capital names, kind of like your constants. Brace placement style. You can actually get people getting into pretty heated arguments about this. But basically there are two broad ones with little tweaks. There's one called the K&R style. Stands for Kernighan and Ritchie, the inventors of the C programming language, who wrote the first book on C back in 1970, and they use this style, which is to put the braces on the same line. I personally like this one, where the braces line up like that. I like this one to the point that when code looks like this, I'll edit it and I'll change it to that. If it's my own code. Shouldn't do that to somebody else's code unless, they quit and it's okay to, change the code. But you can see the difference. And you've already had the experience that when Visual Studio is editing code, it tends more to go to this style. And if you choose to reformat it, it tends to go back to that style, I believe. There's probably a way you can change that. Java, Sun, and Oracle also approved of that style, and so NetBeans defaults. That's the Java editor. NetBeans defaults to that style, but you can change it. So I don't care which one you use. I don't even care if you're consistent. I'm just trying to make you aware of the fact that you can put some thought into it. What I do care about is whether your indentions are good. Not your intentions, but your indentions. And why is that? Let me open up one of our older programs. All right, if I open up your code and it kind of looks like that with some things tabbed over too far and other things tabbed over like that, and you have if statements like this. I'm going to write a stupid if statement just to prove the point. And then you have a brace and it doesn't start tabbing over, then then int y is equal to 4, you know, and maybe you've got, you know, a brace over here, whatever. That's really, really, really poor. It wouldn't be accepted at a professional programming house. You shouldn't accept it either. Why? It's just hard as heck to figure out what it's doing at a glance.
Will it still run?
It'll still run, weirdly enough. Some languages are very picky. Actually, I can only think of two where which column things are in is important. And specifically Python. Python flat out would not run if you don't do the indentions right.
What's the other one?
COBOL, I believe, used to be positional. I'm not sure if it is anymore. The reason Python is sensitive to it is because they don't use braces. So if you want to get an if statement to work, if a is equal to 3, then print a. See, Visual Studio's arguing with me. Anyways, there's no brace. In C++ and in Java and some languages, you can leave braces out if there's only one line of code underneath the if statement. But in Python, there are no braces. The only way it knows how the code is structured is by how far it's tabbed. So that forces you to use good tabbing. But anyways, it's not hard to fix that. If your code starts looking like that, just highlight it all. How did I highlight it all? I hit Control A. There's probably also a select all under Edit. Select all. And then go to Edit, Advanced Format, Selection or Format Document. And if it works, it did. You know, now it's all nice and clean again. And it didn't even mangle the placement of my braces this time. I'm impressed that it did not. I want to experiment with that.
For you, if you just type it all out flat, can you format it?
Well, as you type it, it tries to format it for you. It tries to be helpful. Yeah. If I type if parentheses 3 is equal to 3, and then I type a brace, it goes to some effort to try, you know, to tab things and stuff like that. But if it's when it messes up that it's a problem. And it's easy, like especially if you're cutting and pasting code from one part of your program to another, it's easy to mess up the formatting. It's not like a problem if you mess up your formatting. That's just a given that you're gonna. But what's also a given is that you should try to fix it. And I'm not going to fail your program because it was badly formatted, but please just learn, take pride in your code. You wouldn't turn in a book report that was written in crayon or where there were coffee stains on the paper, you know. So there's some other interesting things down here under this Edit Advanced menu. And I know that the words are too tiny for y'all to see, but one of them is called Comment. You can highlight a chunk of code, choose Edit, Advanced, Comment Selection, and it puts the / in front of it, and it comments it all out. So in one fell swoop, you know, you can mark off a big chunk of your code. Why do you want to do that? Well, maybe you're going to rewrite it or whatever, you know, something like that. What else is there under the Edit menu? Edit, Advanced, make uppercase. Hey, that's cool. That broke the program completely. We don't want to do that. Edit, Advanced, Tabify. Tabify turns spaces into tabs. Untabify turns tabs into spaces. Meh, I don't care about whether you use spaces or not. View white space. All of a sudden it's showing all of our tabs with these little arrows. Is that useful? Well, I don't usually find it useful. It clutters the interface to me to have dots where my spaces are, you know, but whatever. I will undo that. If I can spot it. Here it is. Okay. So those are our coding standards as they exist right now. Comments. I would like every CPP to have a header block with your name and your date and what the program does. Also, I would like you, this is nitpicky, I'm not going to ever count you off for not doing this, but it's just a good habit. If you write a while loop and it's got more than a few lines of code, at the end brace of that while loop, put // end while. And, you know, when you're down at the very bottom of your program and it's yelling at you because you don't have too many closed braces, or you have too many, you know, don't have enough, or you have, you know, too many, then when you're trying to figure out where your code works, if you have commented your braces, it's a lot easier to follow. And so, for something short and simple like that, if I would ever want to check to see if 3 is equal to 4, there's absolutely no reason to put int if 3 is equal to 4. But if I had a huge block of code inside an if statement, if 3 is equal to 3, you know, and then I started a curly brace, and then I went all the way down here and I commented it there. You know, when I'm looking at this, the beginning of it is so far off the screen, I have no idea. Is this the end of a loop? Is it the end of an if statement or whatever? You can find out what that is, though, pretty easily. This is a cool keystroke combination. And I'm not sure that it works, which editors it works on and which not, and if you're using a Mac, how you emulate it. But if you hit Control and then the closing brace, but you don't have to hit Shift. You know, the closing square brace, it jumps between those braces. So when your code gets out of whack and you can't figure out where your braces should go, then you can figure out where the opening and the closing one are. So for example, here's an itty-bitty program, itty-bitty brace. It's just going to jump between those two. If I put my brace here, it's going to go to the bottom of the program. I would put end main there. I would put end if, whatever that clause is. The more information you give, the better off you are. Then the last thing is document your variables unless they're just absurdly trivial. You know, you don't need to do string name. This variable holds the name of the user. Or maybe, you know, it would be better to call it username if that's the case. But that BMR program, the formulas were all written using 2-letter variable names. You don't have to keep them like that, but you could. And so if you have a float named HT, then you would say height of in inches. And then if you see float WT, explain weight in pounds. Would it be better to actually include those units as part of the name? Sure. And whatever the other measurements were. Oh yeah, age. I can't believe that whoever wrote that assignment originally had AG as the abbreviation for age. But anyways, AG. Okay. Age in years. Whatever. Try to put a comment on every non-trivial variable unless it's just so blatantly obvious. And that's leaving a huge loophole. But, you know, try to do that. That's fairly professional to explain what your parameters are. And we'll get into other ones as we go along. Does that make sense? Just kind of guidelines to follow. I'm not going to stomp on you if you don't. It's good practice. If I ever do decide to get more picky, I will tell you. All right, we know what comments are. I'm going to ignore this part. Named constants. A named constant is something that's defined with a const keyword. In one language, instead you put the word final there rather than const. I don't know why they chose that word. Otherwise, it looks exactly the same. Const double tax rate is equal to that. So if I come over here and I define that, and then later on I'm trying to calculate the cost, cost is equal to, or the total, we're going to need a cost variable for this to work. Float cost is equal to 10. And then double total is equal to cost plus cost times the tax rate. Like that. Why do you put them in caps? It kind of leaps out at you when you're looking at it visually. Oh, I know what this program's doing. If you just called that TR, and you made it lowercase, it would not be nearly as clear what that was doing. If you can make your variable names good, then you don't have to put as many comments in your code to explain what's going on. You know, that becomes pretty clear what's going on right there. Also, why do you put it in caps? That just warns the next person who's coming along that they can't change that. If they do this, tax rate is equal to 9. It underlines it and tells you that that's an error. Why? Because it's defined as a constant, so it cannot be redefined once it has been defined unless you come up here and edit it right there in the source code. What do you use constants for? For values that should remain fixed throughout the running of that program. So you have variables and you have constants. Programming style. That's the visual organization of the source code. Put blank lines and space and tabs in there to make it easier to read. But that does not affect the syntax of the program, but it does make it more readable. All right, we're done with that chapter. Onward and upward. Why do I only have 2 PowerPoints there? Okay. Bless you. All right. Now we do have chapters 3 and 4. Or at least 3. Where'd 4 go? Oh well, good enough. Expressions and interactivity. We have already been using expressions. Expressions are things like height times weight times whatever. And now that I'm thinking about it, I want to ask this question. I saw this done a lot in the BMI program. Main, void main, whatever. People did this. Float or double x is equal to 703, and then they declared their height and their weight. Did I write a program that demonstrated that? And the reason I ask is about 7 of y'all did it like that. And so when you were calculating the BMI, it looked like this. Float BMI is equal to x times weight divided by height times height. Something like that. Somebody fess up. Did I demonstrate that? Why did everybody choose x as a variable name for the conversion ratio? Y'all all copied each other? Come on, somebody tell me. Did I demo that or not?
Yeah,
I did. Okay, thank you. I did not remember that, and after about the 4th person did it like that, I was like, I don't remember doing it that way. Okay, good. I knew y'all didn't copy because the programs were different. It's just puzzled me. Okay.
I don't usually even, when I'm coding, I don't really even put a raw variable. If I'm going to do that, put 703 down there. I'm going to make it something. I'm going to float x and make it 703.
Right, yeah. So, if I was going in a case like that, it would be better to do something like this. Constant int BMI conversion, or whatever, is, can I spell right? Conversation? No, I'm kidding. Conversion equals 703. And then later on down here when I needed to calculate the BMI, BMI is equal to BMI conversion. That's a bit long of a variable name. Times weight divided by height times height. Like that. That makes it real clear. Or you're just going to plug in 703 there. But then if you revise this program to work with kilograms and meters, you're going to use a different conversion. So anyways, making it X and demoing it as X to y'all should not have been what I showed you. It should have been a more meaningful term. Whether it was in all caps and made a const or not, you know, even if it was just called BMI underscore conversion, conv like that, or BMI ratio or anything other than a single letter variable name would have been preferable, and I showed y'all putting it in X. So there, I've slapped my wrist twice.
That's not what you're going to do to us if we mess up. Is it?
Oh yeah, nope. Not allowed to abuse people anymore. Notice I said anymore. I'm totally kidding. The CIN object. All right, we don't really need to talk about this. It reads from the keyboard. You have to include IOStream in order to use it. You use two arrows to read, and the arrows point away from CIN. And these are called the stream insertion operator. I swear we've seen this slide before. Displaying a prompt. Displaying a prompt is when you ask the user to enter some data. So you tell them what you want to enter, and then you let them type it in with CIN. Are there more than one ways of printing information on the screen? Yeah, there are other commands that display information on the screen, other functions besides cout and CIN. And other languages do not use this stream concept at all. So you'll see something much different when you go to C# or Java, Python. You can read in multiple things at the same time with it. You could do this. Why do I keep closing my notepad when I'm keep typing? You could do cout, enter first and last name. Then you could do CIN and read in their first name and their last name, like that. Whatever they typed in first would go there. Whatever they typed in second would go there. If they typed first and hit enter, they wouldn't see anything else until they typed in the second thing. Whether you think that's good, I'm not sure. I think it's good. But let's get a new project going. Where'd my boilerplate go? All right, so I'm going to make two variables. I'm going to include strings so that I can work with things like names. Then I'm going to come down here and do cout, enter first name and last name. That's pretty clear. Put the semicolon in the wrong place. There we go. I need two variables to hold this data, so string first name, comma last name, and then CIN directly into first name and then into last name. And now we're going to print out a message. We're going to print out the last name, followed by a comma and a space, followed by their first name, followed by an ENDL. All that does is reverse the order of the data that was displayed, that was entered. So it asks me enter first last name. I say that my name is Bob Roberts, and it prints Roberts, comma Bob. If you want to ask them to enter data like that, that's fine. Just be kind of warned that if they type in only one thing, it's just going to sit there not doing anything. So run, enter first and last name. All right, my first name's Bob. Oh no. Now what do? I call you up and yell at you. Okay, Roberts. There we go. So just a side effect. What this is doing is whatever you type is buffered so that it can then be sent to the keyboard, to the program. And when it does this arrow thing, it tries to retrieve what is known as a token of input. Anything separated either by a space or by a character turn or a tab is considered a token. Let me run this program again and then type a tab between my first and my last name. It'll still work. Joe, tab, Bob. And it prints Bob, comma, Joe. So that works. This is considered a token of input. That's considered a token of input if I type them on separate lines. Or if I don't enter anything, I hit enter, I hit enter, I hit enter. Oh, it really did want me to type something in. Joe. No, I don't know what I'm doing. Okay, Bob. That's still two tokens of information. Not all input functions work this way, but in the stream operators do. These arrow operators work like that. That can, another consequence of that. Cout, tell me your 3 favorite numbers. No, I'm going to rewrite that. Cout, what is your age? Not your age. We need a variable, so int age, cin into age. Cout, what is your favorite food? String food. Cin, read that into food. Cout, what is your fave color? String color. Cin into that color variable. And now let's just output all of those things. Age, followed by a space, followed by the food, followed by a space, followed by the color, followed by ENDL. And I think I'm going to change those spaces a little bit so that they are commas rather than spaces, just so that it visually is distinguished from what I am going to show you. So when I run this, you saw how I could get behind the input if I only typed in one thing and it wanted to, then it would just sit there waiting, with nothing on the screen, with nothing additionally being printed until I actually typed in a second piece of information. The opposite can happen. Okay, so if I type in Joe, and then it's still waiting for something, Bob, that works great. Now age, 12, favorite food, pizza, color, red. And then it prints 12, comma, pizza, comma, red. But I can get ahead of it if I want to. I'm not sure why I would want to. Jeff Thompson, 12, pizza, red. It filled in all of those questions based on this. Even, it didn't even get a chance to display this stuff. I mean, you know, it displayed it after I typed it. What is your age? What is your favorite color? You know, all of that got displayed after I typed all this, and yet it worked. So when it finally printed it out, it printed, you know, the age and the favorite food. So I buffered that input. I gave it all at once. So if you have something that's going to repeat over and over and over, asking for a number, like if you're writing a scores program, and then the user decides to enter 3 scores in a row separated by spaces, all 3 of those values are going to be accepted and read into that scores variable in turn. Unless you do something to clear the input buffer between reads, which is possible. You can do that. You can say, ignore everything that was typed up to now because I want to make darn sure that they give me fresh data. Do you need to take advantage of this? No, but when you see me come over and try to work on your program, and it's looping, asking for, you know, a series of numbers, 10 numbers, I may type 5535, you know, with spaces in it just to try to speed it up. Order is important. The first value goes into the first variable, etc. Mathematical expressions. The act of composition is turning a formula into something that a programming language can accept. If my formula in the book is pi, or 4/3 pi r cubed, like that, I can't type that into a programming language. I could try to do something like this. 4 divided by 3, okay, pi, well, I'm just going to use the word pi, r, 3. That's not going to work. It doesn't know what's going on there. Let's get a little bit closer. 4 divided by 3 times pi times. Just because you put 2 things together inside the computer, inside the programming language, doesn't do a multiplication like it does when you're writing a math book. When we're writing math, we understand we don't have to put multiplication symbols between all those. When you're putting it in a computer, you have to. And how do we do that? R to the cubed? Well, there's a POW function, which will raise one number to the next. So let's add that to our little silly program up here that was asking for food and stuff like that. Let's ask for the radius. Radius of a sphere. We sure are asking this poor kid some weird questions.
It's just a site test.
Yeah.
We'll figure it out.
Now let's declare a variable for the radius. So double or float radius. Let's read into it. And now let's calculate the volume of the sphere, which is that equation I wrote, 4/3 pi r cubed. I believe that to be correct. I'm going to put a, no, I'm not going to even put a, yeah, I am. Volume of sphere equals 4 divided by 3 pi r cubed. Obviously, that's not computer programming. Double volume. Volume is equal to 4 divided by 3 times, and let's say I don't know how to get the value of pi, so I'm going to just call it 3.14159 times, and now I need to do that r cubed. R cubed means r times itself, you know, r times r times r. It would be totally okay to do radius, don't type this because I'm going to show you a better alternative, times radius times radius. That does mean r cubed. What if it was r to the power of 20?
Can we raise it with a caret?
Yeah, you can't raise it with a caret though. That's the problem. Some languages have exponents support, like that. Don't tell me it's going to work. No. Oh, I still have my caret there. Alrighty. So I have to do one of two things. I either have to use that multiply, that times 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 trick, or I use the POW function, which stands for power of. POW, radius to the power of 3. That takes R and raises it to the power of 3. Now let's print that out. C out, volume is volume
Anything, Matt?
in DL. All right, I think that worked. So that's what composition is. Composition is creating an expression that solves a mathematical equation or whatever you're trying to calculate. This is what's known as an expression right there. An expression is a series of symbols and variable names and numbers or literals. It could just be one number. I could just say volume is equal to 4. That's a valid expression. 4 is a valid expression. Or I could say volume is equal to 4 times 3. 4 divided by 3. That's a valid expression. It's not valid for what we're trying to solve for. You know. Or it could be a long, complex, hairy one like that. That's what an expression is. This is an example of a fairly lengthy expression. And of course they can get much longer than that, but if they do, you probably ought to break it into several different lines, different calculations. Like, now that we've calculated the volume, we might want to do some, physics on it and say, okay, if you have, this many liters of gas or whatever, how much does that gas weigh based on its atomic weight or whatever. You don't want to pile all of that stuff in one amazingly long expression. Instead, you want to kind of divide it into chunks. You calculate the volume first, and then you calculate the mass of the sphere based on its atomic. Yes, sir.
So for doing like square roots and just like roots in general, can you use the power and instead of like when you have a 3, can you use like a fraction?
You
or-
can, but there's also a SQRT function for getting your square root.
Right,
But,
well, I mean,
but
if
you
it's
can
like,
raise it to the power of 0.5. You can do fractional.
so like, I mean, like if it's like a third root or something like that, or.
Yeah. Very good point. If you're trying to get the square root of something, see out power of, I want the square root of 4. That's 4 to the power of 1/2. Kind of weird. Not really. I mean, there's mathematical reasons for that. So if you don't know how to get the square root of something, but you do remember that, you just realize that you have to raise something to the power of 1/2, and it gets you the square root of it. However, I believe we have a square root, I'll come back to you, square root function available to us, SQRT, and that will give us the square root of 4, like that. We could do either one. Both of them will work. When would you use power though? Well, there's nothing that'd take you to the 10th root of something. So you might have to, power of 1 divided by 10. That would find the 10th root of something. Okay, I'll come back and help now.
Looks like the power's not declared in the scope.
Yes, sir.
There's something wrong with these weird installing the no operator phone. Not sure what exactly that means. Try to build it, it won't go anywhere.
Why did that one work and then the rest of them not?
I'm not sure. Okay. Like it works with some strings, but.
Oh, pound sign includes string.
Oh.
There is a string class built in. Does that work?
I'm not sure. Do
I
need to
think you
make
need
one?
to make it on the new line. So that'll fix that. All right, so where's the POW function hiding? On one of these development environments, POW is not available. Let's see if there's a pound sign include for it. Pardon? CMath, okay. Is CMath included by default on Microsoft and not on others? Try that. Type in pound sign include CMath and see if that gives it to you. See if that lets it compile.
Okay, yeah, that fixed it.
How odd. Okay, learned something new. You Mac users haven't been having that include CMath, right? No? Okay, interesting. Thank you for knowing that. Okay, remind me what else is in CMath, if we can. Lots of things. Log, absolute value, cosine, tangent, exponent, is greater than, is less than, some interesting stuff down here. Okay. It has to be default, included by default on our current editor. All right, guys, this has been a pretty short lesson. I want to see if there's anything else in here that I want to cover. Order of operations we've talked about, PEMDAS. We'll make these two slides the last things we do. Let me drag that off the screen so that we can't just see the answers. All right, what's 5 plus 2 times 4?
13.
Yep, why is it 13, y'all? Which happens first?
2 more times 2.
Yeah, the 2 times 4. We already know all this. What's the first that happens here? 3 times 2. And then what's the next thing that happens? All the additions and subtractions are done left to right after that. I'm pretty confident we know this stuff. I think this is about where we're going to stop. Algebraic expressions. That's what I was talking about, the art of composition. If you want to take that, you have to express it like that. And you have to use parentheses to make sure that certain parts of it are evaluated correctly. Why? Because if you worded this like this, that's totally not right, because what would it do first when it was evaluating this? Yeah, it would do that division. And then it would subtract that. So it's like it was written like this. That's how it treats it if I didn't group this stuff with parentheses. So instead I group it accurately with parentheses as I had it. Good place to stop. I don't want to talk about type conversion yet. We didn't really do a lot, but let's go ahead and make an inbox for it. I'm just going to call it CIN because that's pretty much what we played with. All right, if you refresh your Dropbox, you'll see it there.